1, 2, 3, 4, start.
So, good morning friends, and I am Manish Jaswal, and cameraman is my sister Reema Jaswal. So, Reema, what is today's topic? Today's
Space
topic,
time.
yes,
Space Quantanization with dark notes. No?
Space time quantinization with dark
Notes.
notes. Okay. So, like previous episode, suppose we have a physical space. Okay, na? And in this physical space, it is devoid of mass. No mass, no energy. Then this space, this physical space cannot be defined. It is undefined. It is limitless. Okay. We don't have mass, it is okay, no problem. But if we also don't have energy, then this space has no meaning. That means to have any meaning for this physical space, it has some reminiscent of energy, some amount of energy in this space. Energy may be distributed uniformly, energy may be distributed in surfaces, in small volumes, But for simple model, at Professor Sanjeev Kumar Gupta, my graduation college, IC Bangalore, taught us make simple model. So best way energy can be represented so that this space can be categorized. At least you have one physical, in this physical space, at least you have one surface. And that surface can most simply be designed by a 2D flat sheet. And we call it graviton sheet. Okay, cameraman? This is first point I want to make. And of course you are interacting with this video. We in this interaction we are making the second proposition that whenever light travels, suppose one sheet is present between A and B. We draw this diagram outside here for simplicity, and between this A and B, linear distance A and B, this two-dimensional sheet is represented by a single line. Okay. When light passes, for example, this sheet is two-dimensional. When light passes from this sheet, that is from this sheet, it actually changes this 2D sheet into 3D flux, and it gives this 2D graviton sheet change into graviton particle. Something like this sheet, passing of light creates 3D projections. At Professor Leonon's sections talk about in some of his videos. So that means this sheet will look like something like that. Original sheet, look, dotted line, and this sheet is sometimes 3D projections. Okay. 3D projections, up and down. So this become a graviton particle, and it is the passage of light with speed c. Okay. What happens that when light passes between A and B, because this flat sheet changes into 3D projection, so now half of the sheet is also whole of the sheet shrinks, so that now number of sheets become n. How much? Effectively n. and these are not straight.
हाँ जगह भैया.
These are one sheet, which is GP. This is GP. All are GP. This was flat sheet. Flat sheet changed into some rounded particles GP. Okay, because of fluctuation. Now effectively number of sheets have become 1 GP is actually equivalent to 1 sheet. Okay. Now we have n sheets. That means in deep space, suppose we have deep space away from gravity, between A and B we have 1 sheet. Okay. When light passes in deep space, number of sheets increases due to 3D projections. Okay, no problem. Mass, when light again leave the space between A and B, the number of sheets changes into single. So when light enters in this space, number of sheets increases, extra number of sheets actually flows in from the environment. Okay, so number of sheets increases. Now when light passes, number of sheets become 1. That means all these extra sheets come back from the environment. The process is reversible. Then on an average, number of sheets will increase. That is why when light is locked in a space, for example, it creates mass. Energy is locked, it creates mass. But simultaneously, this energy flows from environment in the form of sheets radially. Okay. And during this reversible flow of light, energy also, suppose light is flowing from here, now this portion is empty. That means number of sheets will go in opposite direction. Okay, but on an average, number of sheets in the region containing mass will be more. Okay, this is mass portion, but not only in center it is more, in surrounding region also number of sheets will be more. Okay. For example, if this was the length in A and B in deep space, there was 1 sheet. Reversible flow of light in the presence of mass and gravity means gravity creates extra sheets. Okay, on an average, these sheets are not flat. Sheets in deep space is flat, but these are GP, 3D projections, 3D. Nah? But overall surface area 1 GP, surface area of 1 GP equal to surface area of 1 GS. Okay, whether we have a flat sheet or a flat sheet in a fluctuation, this is known as GS and this is known as GP. Surface area is same. Okay. Now with this point, cameraman, we want to make another point is that whether between A and B we have a flat sheet, surface area of one graviton sheet is represented by 1 GS. Okay, surface area, this is surface area. Okay, and whether in the presence of mass and gravity due to reversible flow of light, there are n sheets, effectively n sheets, but these n sheets are not flat like that, because this sheet has 3D, it is 2D. Now this sheet has 3D projection, so this is 3D. Okay, this changes into sometimes graviton particles. But the surface area of one graviton particle is equivalent to 1 sheet. Okay, this is the effect of mass and gravity. So in deep space, if we represent, for example, in deep space, if we represent energy sheets as graviton sheets as something like that, na? But in presence of gravity, mass and gravity, these sheets have these sheets are fluctuating, na? That is, sheets on an average shrinks. So to accommodate extra sheets, we can visualize these sheets as triangles, na? So closer to mass, more triangles, more number of sheets. These triangles show 3D projections, okay? And with distance increasing, number of sheets decreases, na? This is the role of gravity. This is the role of gravity. Now we comes to the third proposition, whether light passes as a fluctuation, so that this flat sheet changes into two triangles, for example, na? So the sheet shrinks, but surface area is same. Whether surface is flat or it is GP, light covers whole of the surface. Light covers whole of the surface, and it takes time Tg. Whether flat or whether it is shrink, it takes time Tg. Na? Tg. Because surface area is same and light has to cover whole surface. Surface is flat, so in deep space, light covers more physical distance, corresponding to one sheet. Okay, linear distance. But in gravitational field, light covers same area, but physical distance covered is less. But time taken to cover, since surface area is same, time taken to cover both of these surface from one end to other is same, and that same is universal time scale. This is Tg. So Newton stands from the great Newton stands from the grave, from his grave, and said this is universal time. This is universal time. In terms of relativity, we can say that when we are in deep space, we have one sheet. Physical distance of the clock. This is the physical distance of the clock. It has one sheet. So 1 second in deep space is equal to 1 Tg, because light will take 1 Tg second to cover one sheet. Okay. In presence of gravity, effectively in gravitational field we have n sheets. How many sheets? N sheets, because sheets are converted into particles, na? Because of gravitational fields, na? But since a clock works on physical distance, same physical distance here is also same physical distance. So time to travel light from here to here, it is defined at 1 second. So clearly 1 second here is equal to, if there are n sheets and time to cover one sheet is Tg, then 1 second is equal to, it is n number of sheets. So n times, and for to cover one sheet, one flat sheet or one particle, it takes same amount. So it is n Tg, n times Tg. And what is Tg? Tg is the time taken to travel in deep space in one sheet, na? So 1 second in gravitational field is equal to n times 1 second of deep space. 1 second of deep space. So that is, in terms of relativity, Einstein theory of general relativity, 1 second in gravitational field is equal to n times of 1 second in deep space. Okay, this is time dilation. This is time dilation. Now let's forget for some time the role of gravity. Okay. Now we have deep space. We have deep space. Seats are flat. Seats are flat. Okay. And each sheet has same surface area. Okay. And light takes same amount of time. Tz. No problem. Okay. No problem. But suppose light want to travel in straight line. In straight line. From this point A. Now, that means fluctuation will travel from this sheet to this sheet to this sheet. Okay? Okay, cameraman? And when fluctuations occurs, number of seats outside will move inside. Okay? But now suppose light want to travel in just some angle from this side. That is from A to C. A to C. And space is filled with deep space. Now, here seats are linearly arranged. But when light has to travel from in this direction, from this point A, then in this direction seats has to orient itself. Now, seats has to orient itself. That is no single figure. Whether we represent sheets as discrete unit like that, now it will only show propagation of light in this direction. Okay? But to have a general direction, now, for example, if we want to travel sheets in that direction, we want to travel light to move in this direction, now, some angle, then seats must be oriented in this direction. But when light wants to travel in horizontally, then seats must be oriented in horizontal direction. Now, but what is the correct figure? We have to accommodate all the possible directions of light. Light can travel in from one point, from this direction also, this direction also, this direction also, this direction. Nah. That means seats representation for this is good for one direction. This is good for vertical direction, cameraman. Nah. But light should travel in all directions in deep space with equal velocity. Okay. So for example, if these seats are not continuous, these seats are continuous. These seats are continuous. Instead of this continuity, these seats are continuous. That is, space-time quantization is not there. Seats are continuous. So we cannot orient the space according to direction of light like this. Light like this. Because whole of the seats will have to reorientate itself. So, despite this, we quantize seats. We quantized seats as flat seats. So that passing of light may reorient it according to its needs, like that easily. This is the benefit of quantanization, space-time quantanization. But this is not a complete picture. We can improve this model further, cameraman. Okay? How we can improve that? We want our space to represent this orientation of seat also. This orientation of seat also. This orientation of seats also. All these orientations can be represented if we assume that these seats in deep space before passage of light is actually not flat. They are before passage of light itself, they are vibrating. For example, if suppose this is one seat, na? This is one seat. Bigger picture. Zoom in. Zoom in. This seat, na? This seat is vibrating. That is, this is natural length, same surface area. Before passing of light, it is vibrating. That is, when it will vibrate to its maximum, then this length will be, linear length will be consumed. Okay? How to represent? Suppose this is length. This is original length. No. Vibration is there in upward direction, suppose. So length will consumed. Length will consume. Okay. Length will shorten because it is 3D projected. Surface area is used to give 3D projection. Okay. Now same length will be same, but when fluctuation reverses. Fluctuation reverses. Okay. Okay, cameraman. But that fluctuation may be intermediate also. Some fluctuation upward, some fluctuation downward. And this was original length. Now this seat is in 3D. Light passing, na? But before passage of light in deep space, all these fluctuations are taking place. Okay? Suppose simple fluctuation, for example. This is sheet. Fluctuation is maximum. So this. Fluctuation very small. This. Na? Fluctuation more small. This. Na? Now original length. Now some shortening, some fluctuation. Much bigger fluctuation, more shortening. All this time. Na? So it is in, sheets are fluctuating. Even in deep space. Even in deep space. So that means this fluctuation, and this is simple fluctuation. Suppose this sheet, it has only one peak. Na? Height is varying and width is shortening accordingly. Na? This is one peak. May have this simple fluctuation may have more than one fluctuation. Na? Okay. So, and height also vary, for example. Na? Height may also vary. That is, fluctuation will create fluctuating surface. That is, a flat sheet is not flat in a some time of contact surface, circular contact surface. So a fluctuating sheet can be represented on an average in deep space by a something called area of influence, general area of influence. Na? So sometimes this sheet, flat sheet is not flat, it is fluctuation. It has fluctuation in deep space. So suppose two flat sheets are there and there are two fluctuations. Na? They may be in during a particular instant of fluctuation, contact in this direction. So we say sheets are in contact in this direction. Na? These two sheets are in contact in this direction. But during course of fluctuation, this fluctuation breaks. That is, this fluctuation breaks. Fluctuation between these two, contact between these two sheets break. Na? Now this sheet, fluctuating sheet, and just above fluctuating sheet. That is just above fluctuating sheet makes contact. Na? That means on an average one sheet can interact with this side also, after some time this side also, after some time this side also, this side also. Interaction can be made all the direction, because sheet is not flat, sheet is fluctuating. So in every direction fluctuations can be made. Na? Fluctuation can be made. But for simplicity, in deep space, now in gravitational field where mass is there and light is flowing reversibly, so these fluctuations are more. Now in deep space, suppose there are one fluctuation between A and B. Now in gravitational field there may be more fluctuations. Now so if we assume that in deep space this seat is this basic fluctuation, we ignore this fluctuation and we assume that between A and B we have one seat, okay, but it is fluctuating. In gravitational field between A and B there are more fluctuating seats, so we have n seats. Now gravity increases the number of seats, but to make things simple, we assume that in deep space seats are flat, because fluctuation, maybe there is fluctuation, we have shown like that, but corresponding to gravitational field, these fluctuations may be considered flat. Now so in deep space seats may be represented flat, but in gravitational field seats are fluctuating. Of course both are fluctuating, but we have assumed as it base. This is base. Now base fluctuation straight. Now in gravitational field seats are, light is passing reversibly, that's why gravity and mass has been created. Now mass and gravity, so seats may be represented by 3D variations, that is seats are zigzag, okay. This shows fluctuation, okay. That means number of seats have been increased between A and B, because seats are zigzag, so more number of flat seats can be accommodated in gravitational field, okay. Cameraman. So in deep space where there is no gravity, seats are flat, but these seats are actually fluctuations. So this figure or this figure, both represent same thing, okay. Light when travels in this direction, seats make linkages more regularly in the direction of propagation, okay. When same light travels in from this point, travels in just vertical direction, then orientations changes, because fluctuations are more common in the propagation of light direction, okay. That is, flat seats are fluctuating now, and when there is no propagation of light, contacts are random. Sometime here, now this breaks, another time here, now this breaks, sometime here, this breaks, sometime here, so that all the possibilities are represented. This type also, at a moment this side also, na. But when light passes in particular direction, then random fluctuations actually change into order. Now in the direction of propagation of light, these random fluctuations change into permanent, some type permanent in the direction of propagation of light. That is, seat structure, general this seat structure change, contacts are more prominent in the direction of light. So seat structure looks like this. This is the flexibility of time and quantanization. Okay, cameraman.
हाँ लो सब्जी.
5 minutes. No problem. Nothing is there. Only I am smelling.
अरे यार जल जाएगा.
Wait a minute, sir. Dima is saying our vegetable is in the process of cooking. Na? So that is the way we are explaining the things. Na? So this is the way we are explaining space-time quantization. So now we will link. We want to link this thing. Okay. So I want to say is that quantization of space and time into gravitational sheets or gravitational particles helps in the propagation of light in all the directions in deep space with same speed c. Okay. If space is continuous, then propagation of light in all possible directions will not be same. So isotropic properties of space can only be achieved, that is propagation of light in every direction with same speed in deep space can only be achieved if space is quantized into smaller parts, that is gravitational sheets or gravitational particles. Of course, in deep space these sheets are not actually really flat, they have some vibrations, but and these vibrations, these sheets, these graviton particles make random contacts in all direction. But in the flow of energy, in the propagation of direction of light, these sheets make prominent orientations so that random contacts between particles changes into directional contacts and give direction to the light. Cameraman for 5 minutes. Bas 5 minutes. Deep notes, dark notes just coming. Just cameraman takes 500 rupees. Now she is demanding 1000 rupees for making video, and this is absolute corruption. No, she is saying weather is very hot. So now I am moving towards the dark notes. No. So just I am changing the video. Okay, cameraman. Let's start.
ए भाई बस बहुत हो गया.
Now, cameraman.
अरे भाई.
Okay, cameraman.
अरे बोलो ना.
Okay. So, suppose we have mass m, a heavy mass, and there is also another mass m. Okay. Now in gravitational field, sheets are more oriented, more zigzag closer, more sheets are there, number of sheets are more, okay, and it decreases, number of sheets are more but it at decrease. And in deep space minimum number of sheets, but it is not flat, okay. But these sheets are actually in deep space, or whether sheets here or here or here, they are fluctuating. In deep space, we assume that it is flat, but actually they are fluctuating. Another point I want to make is that before passage of light, here light is passing reversibly, creating mass and gravity, so that extra number of sheets are there in gravitational field. But in deep space there is no light, okay. But even here also these sheets are fluctuating, in deep space, so that random contacts can be made. From where this energy comes? Of fluctuation. Before passage of light itself, these sheets have fluctuation, some basic fluctuation, some minimum basic, But we don't represent in deep space, we represent in like flat sheets. But in gravitational field, passage of light reversibly creates fluctuation, it is okay. But in deep space, before any passage of light, there are fluctuations, some basic fluctuation. That means, who give these basic fluctuations? We assume that between two masses, in gravitational field, in deep space, where sheets are actually fluctuating, but we have shown flat relative to gravitational field, these are fluctuating. These are, cameraman, sheets are actually fluctuation. But from where this fluctuation is coming from? Actually, this random fluctuation of sheets, is coming from some type of order. Some type of order is that between masses, these random fluctuating sheets are actually, they are making random contacts. They are fluctuating in deep space. But why they are fluctuating? Because sheets are actually, these fluctuating sheets, before this random fluctuation, they are actually flat. Okay, flat, but they are making some type of contacts in a direction, some type of direction. They are linked. They are showing some long range interaction in direction. Okay? That is between masses, before random fluctuations, these sheets in deep space show some type of interaction which is not random. This is another set of sheets. This interaction, and this is, and they are behaving, and now these interactions are, these surfaces are fluctuating up and down. Okay, so that is, surfaces are fluctuating. These surfaces as a whole are fluctuating between these two masses, sometime like standing wave between nodes. These are nodes, and they are fluctuating. Okay, this is dark photon, dark standing photon. But between these two masses, these interacting gravitational sheets, which are actually fluctuating in tandem, sometime these sheets are making oscillations collectively, but somehow and this set of sheets are making fluctuations. There are different 3 sets of sheets. These are what? Moving in a standing wave like a string. All these 3. But between these two masses, they are acting as nodes. Okay? But now suppose one sheet interact with second sheet, two sheet interact with second. But now this sheet somehow interacts with this sheet. Okay? So that normal interaction is in this way, but somehow this sheet moves in downward fluctuation. Okay, organized fluctuation, and in this second layer fluctuation, this sheet comes in. Now this sheet comes in. So that's why in this dark photon vibrations, which is very ordered over dark photon vibration, standing vibration between masses. Seeds, one seed for a movement may be present in this second portion, second fluctuation. It may be present also in other time in this fluctuation also sometimes. Now, this gives random vibration. This shows random vibration. This causes individual seeds to have random vibration. Okay. In deep space also, because of this long range interaction, these seeds show, when we look seeds, this shows randomness. But beside this randomness of seeds, beside this randomness of seeds, there is long range interaction. So when there is mass, there is gravity, no problem, more organized seeds. But in deep space, seeds are flat, but they are fluctuating, and this fluctuation is actually because of what? Because these seeds are interacting. These seeds are interacting. Suppose one seed, that is, seeds are making some type of standing wave. But since seeds sometimes between masses, this arrangement, they are in some arrangement looks like that, but so this particular seed moves here, so that standing wave change something like that, so that it accommodates just this seed, and this second seed may move in the lower direction. So number of now seeds arranged are like that. But overall there is order, long range order, which give fluctuation to these seeds. Okay. So this is the reason deep space seeds have some basic fluctuation, random fluctuation. Okay. But there is a mass. Suppose there are 4 set of masses. One mass set, second mass set, third mass.
पेज ना बर्बाद करो.
No. This. Suppose we have one mass, we have second mass, we have third mass, we have 4 mass. Okay. Now in deep space, we are talking only on deep space. Seeds are arranged as a standing wave, but between these two masses, seeds have more curvature. In deep space. Okay. And here very less curvature. Okay. Because of this and all these mass and associated gravity, and this gravity is also contains seeds, and in deep space seeds also have seeds. Here deep space, seeds, here mass and gravity, light is passing reversibly, mass and gravity, light is passing reversibly. This is deep space. But all these things are forming some type of mass, deep space and gravity are something arranged in something like nodes. Mass, deep space and gravity, all these things are some type of vibrations with different amplitudes. Na? So this is deep space 1, this is deep space 2. Here mass and gravity, here mass and gravity, here mass and gravity. Okay, but in deep space vibrations are different. Vibrations are different. Okay, so what you will see that here curvature of sheets are different. Individual sheets are. So what is our model? In mass sheets are curved, but in deep space it is flat. Okay, but in this region these are not flat, these also have inherent curvature because of this model of black photon. But in this region we have same mass, gravity, the sheets are more curved because energy, standing wave black photon energy is localized here. Okay, that means situation is same, but since sheets are more curved, that means here gravitational probability will be different, here will be different. Of course, with distance 1 by r square law will hold. So force equation between these two nodes in the another part of universal field will be given by G1 times M1 into M2 between two sets of masses, same two sets of masses, like that. But in another part of universe it will be given by G2 times M1 M2 by r square. Gravitational content will be different for different regions of space. Why this is happening? Next point and over. Why this is happening is that because we have two masses and light is flowing reversibly. Light is flowing reversibly between mass and gravitational field. Light is flowing reversibly so that energy is restricted in mass and gravitational field. Okay, in a light, reversible flow of light, cyclic flow of light created mass and gravitation. Okay, light flows here, back here, here. Light flows here, back here. Nah, mass and gravity is created. But in deep space there is no effect. There is, sheets are actually non-vibrating, flat. But now suppose there are more mass sets. Suppose there are 4 mass sets, like in constellations. No, like in constellations, mass sets. So this is gravity, this is gravity, this is gravity, this is gravity. Nah, light is flowing reversibly. Mass and light is flowing reversibly. Light flows reversibly. Nah, creating mass and associated gravity. Nah, but in deep space, reversible light from here interacts with reversible light from here. Nah, and there may be, when two masses may be some interaction, so some fluctuation. Reversible light may come to here, reversible light may come to here, may be some interaction, no problem. But projective simple model occurs. But when masses are in some particular arrangement, then reversible light from this mass M1 interacts with here, reversible light from here interacts with this. Now, so reversible light, R light interacts with R light 1 interacts with R light 2 fluctuation. Similarly, but this is simple model. So there are 4 set of mass. So what we are showing that in deep space, around 4 set of masses or n set of masses and reversible light which create gravity and mass. Reversible light which create gravity and mass. In deep space, all these actually reversible light L1, reversible light L2, reversible light L3, reversible light L4, all interact in deep space. All interact in deep space, and that's why behavior of gravity is different here. And that's why between in general set of masses on gravitational level, deep space fluctuations, basic fluctuations may be more curved between constellations, and deep space basic fluctuations may be flat nearly. Okay? And that's why mass, gravity, mass, this is gravity, and this is deep space. This is second set of mass. This is deep space, but this deep space is different from this space. This gravity is different from this gravity. Now, when all these systems we see in unison, we have nodes. Of course, in this nodal region, we are seeing a visual mass, we are seeing the visual gravity, we are seeing a visual mass, visual gravity, visual mass and visual gravity, but between these nodes, deep space seeds, they may have different set of black standing photon vibration. Here, long range vibrations may have less vibrations. Okay? That's why in set of where constellations are present, value of G will be greater than G2, or most in different parts of the universe. Between different self-contained fluctuation long range nodes, between these two nodes, between these two long range deep space fluctuations, and in this unison picture of node, more fluctuations, that is seeds have more fluctuation, that's why they are more curved. Okay? And between these two other nodes, less fluctuation, that is seeds interact and seeds are less curved. Okay? And between these nodes, you may see visible mass and gravity also. Visual mass and gravity also. But in deep space, since seeds are more curved here, the nature of gravity will be different here. Here in deep space, this is another set of standing wave. This is another set of standing wave. Overall, this is one set of black photon. This is black universal photon. Black universal photon. But between these two nodes, it has different amplitude. Between these two nodes, it has different amplitude. That's why gravitational constants in this region of space will be G1 will be not equal to G2. Of course, format will be same. Newton will be happy that his format is same. M1 M2 upon R square. This format will hold, that is with distance from mass, gravity decreases. Gravity decreases in the same way. But between these two nodes, invisible nodes, mass is visible, but these nodes are not visible. Between these invisible nodes, because nodes are some type of model only, mass is a property. But these long range interactions do not create mass. These long range interactions, that is interaction between nodes of a black photon standing wave, creates curvature, creates long range interaction, but don't give the property of mass. It only says that sheets are more curved in this space, here they are less curved. Okay, that means when light falls reversibly here in this region of space, mass will be created and gravitational field will be created, but that gravitational fields are made up of more curved sheet of deep space, and here mass and its gravitational field is made up of less curved sheet of deep space. For but of course with greater distance gravity will decrease, but for same set of properties of mass m1 and m2 and same distance, g1 will be different between these two regions of space. Notes between these two regions of space m1 and m2 by r square. Okay, cameraman? Simplest way I want to say is that over now is that everything is over. We have a flat sheet. It is represented as in deep space. Now light as a vibration creates vibration. Now, but when two vibrations collide in two sheets, these vibrations form closed loops. Now, but since sheets are flat, these closed loops have no charges. But dark standing photon model, long range interaction between the sheets creates curvature. So that symmetric fluctuations now became unsymmetric. And when these fluctuations collide, then two set up. When positive charges close, positive charges are formed, and when negative charges, now they are unsymmetrical because basic sheet is curved. Basic sheet is curved because they are curved because of standing photon on very large level of universe. It creates negative charges. So for the creation of these are massless positive charge, massless negative charge. For creation of massless positive and negative charge, we need a sheet, a flat graviton sheet. We need a symmetrical vibration of light, okay, but we need an extra vibration of sheet which comes from dark photon, so that sheet curved, and so that this symmetrical vibration of light, when these vibrations collide, these symmetrical vibrations change into unsymmetrical vibrations, and vibrations flows into different set of charges. This is known as symmetry breaking. Now what is mass? Suppose 2 minutes. What is mass? Now when these two fluctuations collide on two graviton sheets, curved sheets, now positive mass one sided and negative mass one sided, massless particles. Positron electron pair is formed. But suppose all the positive charges, positive vibrations centered around. This is the field of nucleus. Okay? This is the field of nucleus created. All the positive charges are centered around. All the negative charges are one-sided, are in radial direction, for example. Simple model. Now what will happen? These massless particles diffuse in some type of volume, because vibration will open and this change positions. So if we represent now in this volume, if we represent the 1 minute and it is over. Now, so positive vibrations in one point, negative massless particle or Higgs negative particles are another side with different densities. Now, for example, in this volume, density of negative massless particle is represented by psi xt. Psi xt. Okay. So net diffusion at this point x will be given by net density change will be given by diffusion, net diffusion from this surface. It will be given by minus d times d square x square psi xt, where psi xt is the concentration of negative massless particle. Now these massless particles, net diffusion, these massless particles, these two negative massless particles overlap. They are log. They create mass. So here if mass is present, it is also moving. Now, it is also moving. Suppose this at this position mass is present due to coalescence of particles. So its velocity is given by potential energy as a function of potential energy b times, and this moving particle will rebound this massless particle also. So overall particles net diffusion one term, rebound term mass and massless particles rebound it, then second term b times ux multiplied by ux this second term, and what is third term? Massless, all these net massless particles, negative massless particles coalesce to form mass. So there will be third term s times ux multiplied by, and this is effective collision. So this is d times derivative by derivative d of x of psi xt. That is, overall we have, if we balance the massless particle density at particular location from nucleus, where electron sometimes solid is present, and massless particles are present, and these coalescence of massless particle create this solid mass and cloud. So this equation has three terms. Net diffusion of massless particles minus d times derivative square x square psi xt. Second term, mass and particles interact, b times ux multiplied by psi xt. Okay. And third terms, these massless particles create overlap. Overlap of massless particle create mass cloud. So that number should be decreased from this overall balancing equation of negative massless particle. So if one of the particle moves with the particle or cloud velocity, another particle's speed and density can be represented by minus d times derivative by derivative x psi xt. So in this physical model we have three terms. One term double derivative, without derivative, and single derivative. That's why in Dirac model we need three terms. That is I h cut derivative by derivative of psi is equal to mc square psi without derivative term minus I h cut c sigma alpha x derivative by derivative x psi, and we need one term more, and that term is minus space constant time derivative square x square term and of psi xt and multiplied by h cut square by 2n. Three terms. That is, when we say cameraman
अब बस हो गया.
okay, thank you.
उल्टी आ रही है, लो पकड़ो.
Look, give me over. Now 1 week over. Look, cameraman, close it. रीमा, ये स्केच पेन बंद कर दो. So now our model is complete, and with this graviton sheet model and with this black photo model. रीमा इसको बंद कर दो भैया, इसको हमारा ढक्कन गिर गया है. So Rima has done a very hard work. Now after 1 week I will make my work is now over, but in science work never ends. No, in science work never ends. But what I want to say as a layman, and to connect general relativity and quantum physics, we have some time of graviton model. We need, because gravity is present everywhere. In deep space also, where there is no gravity, there are graviton sheets. And these sheets come closer by fluctuation because of reversible propagation of light, and they create mass and gravity which we visualize in our life. But in deep space, there are graviton sheets, and from these graviton sheets of deep space, mass and gravity is created. Okay, so with this graviton model, different aspects like Higgs negative massless particle, Higgs positive massless particle, neutral massless particle, propagation of light in deep space, in why space-time quantanization, why gravitational constant may differ from one region of space to other space, dark gravity, hidden gravity, or dark matter in the form of dark nodes. We feel only mass, but we don't feel dark nodes. That gives extra gravity. Many things we have tried to cover with this model. Of course, I may be totally wrong, and with me, since you are also watching, so we may be totally wrong, but at least a new debate may be generated in the scientific community, not only in India but across the world, at every level, from basic, intermediate or high skill level to the university or postdoctorate level, or at scientific level. A debate can be created to unify the general relativity and quantum physics. And in this centenary year, as a layman, we want to give tribute to great scientists of our world, Sir Isaac Newton, Albert Einstein, present day modern scientists like Roger Penrose sir, Khalil sir, women scientists are also there. And yesterday there was a birthday of the great mathematician from India, great Srinivasan sir, and to his guide Hardy sir. So that is the way a person from outside university want to interact with persons in university and give tribute to the quantum physics, where everyone has contributed, from Heisenberg to Schrödinger, of course great Bohr-Einstein debate, all these things. And this graviton sheet model means sketching, visualizing energy in the form of sketch. Something I think some Richard Feynman from another universe gives some tuitions to me, some blessings to me, so that I represent energy like sheet. And how these sheets change into massless particles, how these massless particles overlap to create mass. We are redefining mass now. So we have extra videos on YouTube, Rima Jaiswal official, and where you and we can communicate with each other. I have some vision problem, so a professor from Ghana a respected professor from Ghana has tried to make a message to me, but because of vision problem I am unable to interact with him. So if he is listening, so I am sorry, sir, but that is the way I am interacting with the world and seeing these 2D holographic surfaces like great Stephen Hawking's some portion sometimes because of the vision problem. I am visualizing. I am not going in deep great tensor mathematics of Einstein, but by simple differential equations, Schrodinger-like equations. I am trying to connect this general relativity and quantum physics. Jai Hind, Jai Bharat, Jai Vish. Once again, I am thanking Rima, my sister, who made very who do very laborious talks to make these live videos, so that on paper and pen things can be visualized very clearly to you, can be visualized by you very clearly. And now I am ending this series, and maybe after few days live videos will be deleted, but of course you can watch some part of my story in YouTube. And after some type of gap, because I also need some rest, I can revitalize you from my all these rubbish or garbage fancies. Take a light note. We should always be in some kind of light mode, so that serious discussions and new ideas can be received. We should not reject the new ideas, because we have become more and more usual with the old ideas. So when you are in some type of light mode, you will be ready for testing, adapting newer ideas, which initially may look like like garbage or rubbish, but in light mode you will have extra capacity to create things from this garbage ideas, from these wild ideas. Like great scientist of black hole, John Wheeler. Jai Hind, Jai Bharat, Jai Vish. Thank you, sir.